The killer whale is the most dominant predator in the history of the ocean. Not one of the most dominant, the most. In recorded marine history, there is not a single confirmed case of any animal successfully hunting and killing a healthy adult orca. Not a great white shark. Not a sperm whale. Not anything. Orcas hunt in coordinated packs, communicate in complex dialects, and have been documented teaching each other new hunting techniques across generations. They have been filmed intentionally beaching themselves to snatch seals off rocks. They have figured out how to tip over ice floes to knock penguins into the water. They have been recorded drowning blue whales, the largest animals that have ever existed on Earth, by holding them underwater in teams. Nothing in the ocean has ever made an orca run, until researchers started noticing something they couldn't explain. Pods of orcas in the middle of active hunts, surrounded by food, completely in control, suddenly stopped, dropped everything, and fled. Not slowly, not casually, in a visible panic, moving at full speed in the opposite direction. The thing they were running from wasn't bigger than them. It wasn't faster than them. It wasn't more intelligent than them. It was a pilot whale, an animal that primarily eats medium-sized squid. An animal that, compared to a bull orca, is almost small. And what the pilot whale does to the most feared predator in the ocean is one of the strangest things happening beneath the surface right now. Before we talk about why orcas run from them, we need to establish what a pilot whale actually is, because on paper this makes no sense. Orcas average around 20 feet long and weigh up to 13,000 pounds. They have 40 to 50 interlocking teeth designed to grip, tear, and crush. Their jaws can generate enough force to crack bone. They are built, in every biological sense, to kill large things efficiently. Pilot whales average around 15 feet and weigh roughly 6,600 pounds. They are technically dolphins, despite the name. They have rounded, bulbous foreheads and a slightly dopey appearance that makes them look like they wandered into the wrong part of the ocean. Their diet is almost entirely medium-sized squid, not giant squid, not seals, not other marine mammals, just squid. In a one-on-one confrontation, an orca wins. Every time. It's not close. So why, when researchers played underwater recordings of pilot whale calls through speakers in known orca territory, did the orcapods immediately abandon their hunting grounds and move miles away from the source of the sound? Not one incident. Consistently, repeatedly, documented across multiple research teams in multiple locations. The orca, an animal with no natural predators, was running from a recording of a squid eater. The answer has nothing to do with size, and everything to do with numbers. Orcas are famous for hunting in pods. This is the entire reason they can take down animals much larger than themselves. A single orca cannot kill a sperm whale. 20 orcas working in coordinated shifts absolutely can. The pod is the weapon, but orca pods have limits. A typical pod runs between 5 and 30 individuals. An exceptionally large gathering might reach 50 or 60 inches, unusual circumstances. Pilot whales don't have pods. They have clans. In the North Atlantic, it is completely normal to encounter a pilot whale group of 100 individuals. Some recorded gatherings have exceeded 500. And unlike the orca's carefully coordinated hunting pack, pilot whale clans are socially bonded at a level that borders on fanatical. They do not abandon each other. They do not retreat. When one member of the clan is threatened, the response from the rest of the group is immediate, automatic, and collective. Here's where it gets genuinely strange. When pilot whales detect the acoustic signature of orcas nearby, they don't do what every other marine mammal does. They don't dive, they don't hide, they don't redirect their course to avoid contact, they move toward the sound. Scientists call this behavior attraction to predator calls. The pilot whales actively seek out the orcas. And when they find them, they don't approach cautiously, they charge. Picture what this actually looks like from the orca's perspective. You are an apex predator in the middle of a successful hunt. Your pod is coordinated, communication is flowing, prey is contained. Everything is working exactly as it should. Then the acoustic environment changes. Pilot whale vocalizations on the perimeter. 1 or 2 at first. then more. Within minutes, 60 to 100 pilot whales are converging on your position from multiple directions simultaneously. They are not approaching cautiously. They are forming what researchers have described as a wall, a physical mass of bodies moving at speed, flanking from every angle, closing the distance fast. And they are screaming. This is where the pilot whale's real weapon comes into play, because the orca's most critical sense isn't sight, it's sound. An orca's echolocation system is so precise, it can identify a single salmon by the acoustic signature of its swim bladder hundreds of feet away in total darkness. Sound is not just one of the orca's tools. Sound is everything. Without it, an orca is essentially blind. Pilot whales are among the most acoustically active animals in the ocean. When 100 of them arrive simultaneously and begin vocalizing at full volume, the decibel level creates what researchers have described as an acoustic wall. The orca's sonar becomes useless. They cannot locate prey. They cannot communicate with their pod. They cannot coordinate. Beyond just the noise, there is a leading hypothesis that pilot whales engage in deliberate acoustic jamming, mimicking and overlaying orca calls with their own complex vocalizations to specifically disrupt echolocation. Not just creating noise, creating the right kind of noise, targeted at the orca's specific frequency range. The apex predator has been functionally blinded by a squid eater. Here's the part that explains why the orca doesn't just push through it. You might be thinking, fine, it's loud and chaotic, but orcas are physically stronger. Why not just fight through the noise and hold their ground? This is where biology produces one of its most counterintuitive rules. It's called the apex predator paradox. And it goes like this. The higher you are on the food chain, the more you have to lose from any physical confrontation. A pilot whale that gets injured in a fight with an orca might survive. Pilot whales are not dependent on physical perfection to feed. They swim in groups. If one is compromised, the clan compensates. An orca that gets injured cannot afford the same outcome. Their hunting strategy requires speed, precision, and full physical function. A broken jaw means the orca cannot grip prey. A torn dorsal fin affects hydrodynamics and speed. A deep muscle bruise from a 6,000-pound animal hitting it at 20 miles per hour means the orca cannot hunt efficiently. If an orca cannot hunt, it cannot feed itself. If it cannot feed itself, the pod, which operates on brutal efficiency, may not wait for it to recover. Evolution has made orcas extraordinarily intelligent, and part of that intelligence is the ability to calculate risk. The pilot whale clan is not a guaranteed kill, it is a guaranteed fight. And any fight, no matter how likely to be won, carries the possibility of an injury that ends everything. The math is simple. Leave now. Find seals somewhere else. Seals don't have 100 friends willing to die for them. The most powerful predator in the ocean runs because it's the smartest decision available. If orcas simply avoided pilot whales and the story ended there, it would be remarkable enough. But pilot whales don't just defend their territory. They go further. Marine biologists studying long-term interactions between these two species have documented pilot whales following orcapods for miles, sometimes days after the initial confrontation has ended. Long after the orca has left pilot whale territory entirely, the pilot whales are not trying to eat them. They are not defending anything. They are just following the orcas, bothering them, disrupting their attempts to socialize, rest, and hunt. It is, by every reasonable scientific interpretation, harassment for its own sake, deliberate and sustained annoyance of an apex predator. And then there is kleptoparasitism. Orcas are meticulous hunters. They will spend hours coordinating a hunt, herding schools of herring into a contained bait ball, working as a team to compress the fish into a dense mass before feeding. It is a complex, energy-intensive operation. Pilot whales have been documented arriving at the precise moment the orcapod is ready to feed, screaming into the area at full speed, scattering the bait ball completely, and then leaving without eating a single fish. They destroyed the hunt for no nutritional benefit whatsoever. Scientists have a word for intentional resource destruction that doesn't benefit the destroyer. They call it spite, and spite is extraordinarily rare in the animal kingdom. The only other species documented to routinely interfere with orca hunts out of apparent choice is the humpback whale, which will travel miles toward the sound of an active orca hunt just to physically block it with its body. The ocean, it turns out, has formed something of an anti-orca coalition, and the orcas are not winning. Here's what all of this looks like from above. If you map the movement of orcapods across the North Atlantic over time against the known territories of pilot whale clans, a pattern emerges that researchers have called the cartography of fear. There are black holes on the map, regions the orcas simply do not enter, not because there is no food there, not because the water conditions are wrong, because pilot whales live there, and the orcas have learned through collective cultural knowledge passed down through generations within the pod that those zones are not worth the cost. The pilot whales have drawn borders, and the apex predators of the ocean respect them. The ecological consequences of this are significant. In zones where pilot whales have effectively pushed out orcas, the populations of herring, salmon, and seals that orcas would normally hunt are substantially higher. The pilot whale's dominance of orca behavior creates unintentional wildlife sanctuaries. Smaller animals survive in pilot whale territory not because they are protected by the pilot whales don't care about them, but because the orcas won't come in to hunt them. Fear, not teeth, is managing the ecosystem. But here's where this gets complicated in a direction nobody expected. Orcas are not accepting this permanently. Researchers have documented something new emerging in orca behavior in regions of frequent pilot whale contact. Some pods have begun going silent when moving through or near pilot whale territory, not reducing their vocalizations, eliminating them entirely. Hunting in complete acoustic silence in an attempt to pass through pilot whale zones undetected before the clan can mobilize. The apex predator is developing stealth mode specifically in response to the pilot whale threat. There are also early observations of bull orcas hanging at the fringes of pilot whale groups, not hunting, not threatening, apparently studying them, watching the clan's structure, looking for the moment when a pilot whale is separated from the group, learning in real time how to find the weakness in a system that has been beating them. And there is a larger pressure, forcing this conflict to intensify. As ocean temperatures rise, the historical ranges of orcapods and pilot whale clans are converging. Habitat that was previously separated is overlapping. Encounters that used to be rare are becoming routine. The ecological buffer that kept these two species from constant conflict is shrinking. When resources become scarce and territories overlap, the logic of avoidance eventually gives way to the logic of desperation. Marine biologists are genuinely asking the question, is there a breaking point? Will orcas eventually develop a coordinated counter to the pilot whale mob? Will they learn to divide the clan, isolate individuals, and dismantle the system that has been containing them? If that happens, the dynamic that has quietly shaped North Atlantic ocean ecology for thousands of years changes overnight. The most feared predator in the history of the ocean is currently being managed by a squid eater with a loud voice and 100 friends. How long that lasts is one of the most genuinely interesting open questions in marine biology right now.